A very good morning, ladies and gentlemen, distinguished guests and esteemed participants, and a very warm welcome to the 6th International Research Conference on Smart Computing and Systems Engineering 2023, organized by the Department of Industrial Management, Faculty of Science, University of California. We are ecstatic to have you all here today as we embark on this exciting journey to explore the frontiers of smart computing and systems engineering. I am Sonal Paranavithana.
And I am Abhishni Sudarshan. And together, we have the honor of guiding you through this remarkable event. Over the next few hours, we will witness groundbreaking research, insightful discussions, and collaborative endeavors in the realm of smart computing and systems engineering.
These fields of interest are at the forefront of technological advancements, transforming the way we live, the way we work, and the way we interact with one another. From artificial intelligence and machine learning to innovation and resilience to supply chain management, this conference serves as a platform to explore the multitude of possibilities and potential that these fields offer. Also, we would like to express our appreciation to our technical sponsors, IEEE and IEEE Sri Lanka section. Also, the platinum sponsors, MAS Lineaqua and SLT Mobitel. Their generous contributions have made this conference a reality and enabled us to create an enriching experience for all of you.
To commence the proceedings of this significant occasion, we would like to invite the following dignitaries to light the ceremonial oil lamp.
Dean, Faculty of Science, Professor Sudat Kalingamudali. Chairman, Research Council, Professor Kapila Seniviratna. Keynote Speaker, Dr. Yasantha Rajakaruna Anayaka. Representing the Conference Advisory Committee, Professor Suren Peter. Head of the Department of Industrial Management, Professor Janaka Vijayanayaka. Conference Chair, Dr. Amila Vidhanarachi. Chief Editor, Dr. Chatumika Viratna. Conference Secretary, Dr. Elini Mukanam. Technical Program Chair, Mr. Dinesh Pasanka. Track Chair, Systems Engineering, Shan Jasin. Representative of our Platinum sponsor, MAS Lineaqua, Mr. Supan Sharada. Platinum sponsor SLT Mobitel, Ms. Dilini Jewata. Thank you, everybody.
Ladies and gentlemen, it gives us immense pleasure to extend a very warm welcome to 5 dignitaries who are present here with us today, and may we have the honor of inviting them to the head table.
May I have the pleasure of inviting the Dean of the Faculty of Science, Professor Sudat Kalingamudali, Chairman of the Research Council, Professor Kapila Seniviratna, Keynote Speaker, Dr. Yasantha Rajakaruna Anayaka, Conference Chair, Dr. Amila Vidanarachi, and also Conference Secretary, Dr. Telini Mahanama.
In honor of our alma mater, the University of Kelaniya, please rise for the university anthem.
Desakitu gosa urumaya suratina siat suwanatina siat suwandaridu kirana bedadena sarasandaki vidulakare udagina kalaniya sarasavi mata kalaniya sarasavi mata Sayuravi Vedanuanadina Satsiluminavi Isuru Sagalana Jai Jiva Ulpadavanno Sindana Kalaniya Sarasavi Mata Kalaniya Sarasavi Mata Siya Desakitu Gosa Urumaya Suratina Siat Suwandaridu Kirana Bedadena Sarasandaki Vidulakare Udagina Kalaniya Sarasavi Mata Kalaniya Sarasavi Mata Sita Surya Tivituru Nanaguna Yugayan Yugayat Kayata Tilinatara Karupirivara Sahamululova Sarasana Kalaniya Sarasavi Mata Vidu Ambare Babaleva Siya Desakitu Gosa Urumaya Suratina Siat Suwandaridu Kirana Bedadena Sarasandaki Vidulakare Udagina Kalaniya Sarasavi Mata Vidu Ambare Babaleva
The Department of Industrial Management was formed with the objective of creating a discipline of science students with management competencies. The initiative was to bridge the gap between management and information technology, integrating the two areas for the first time in the Sri Lankan university context. Let us now pay attention to an introductory video about our prestigious department.
Technology has forever changed everything. From the way we work to the way we think. Humanity is witnessing an unfathomable revolution that has altered man's very existence. Information technology, commonly referred to as IT, is integrated into every industry, be it healthcare, manufacturing, hospitality, and more, making IT professionals sorted in almost every field. Have you ever thought about expanding your horizon and being equipped with both IT and managerial skills? Situated in the sacred city of Kelaniya, the University of Kelaniya is one of the leading universities in Sri Lanka that has nurtured many great personalities. The Faculty of Science is home to many aspiring undergraduates who are about to spread their wings and explore the world. The Department of Industrial Management, one of the very first departments in the science faculty, was established with the aim of molding science students into professionals who are well versed in both management and IT streams. The Department of Industrial Management offers 2-degree programs. Amidst the excellent academic facilities, the department is also designed to provide undergraduates with infrastructure at the level best. Equipped with a library, a multimedia room, and practical labs that utilize up-to-date technologies, the department provides a wide range of facilities for undergraduates pursuing degrees. Apart from the high-quality academic facilities, the department also provides a platform for young undergraduates to enhance their soft skills. The Industrial Management Science Students Association, also known as IMSSA, is the official student body of the department and is one of the most active and prominent student bodies among local universities. It holds the pride in organizing many extravagant events, including renowned hackathons, talent shows, and an industry-acclaimed magazine. The Exposition Magazine, one of the leading university business magazines in the country, is published annually by the undergraduates themselves. The magazine contains articles written by undergraduates and industry experts that provide information on the latest trends and innovations in the industry to those who seek knowledge. The IMSSA also takes pride in organizing hackathons and Inter-University Startup Challenge. It is a platform that enables young innovators to pitch and explore their ideas, preparing them to be the leaders of tomorrow. undergraduates get an opportunity to create essential networks with industry executives while enhancing their knowledge and skills. HackX Junior is an inter-school hackathon organized to provide a suitable platform for the bright young minds of school children to transform their ideas into reality. Rasoga, an intra-departmental talent show, showcases the aesthetic talents of aspiring undergraduates. To enhance the team-working skills and sportsmanship of the MITians and bring forth their young spirit, a cricket match is held annually. Inculcating the essence of giving, the students are also encouraged to host a dansela once a year. The graduates with both management and IT expertise, equipped with soft skills, step into the industry as multi-talented, versatile and well-sorted professionals locally and internationally. The Department of Industrial Management is the pioneering academia to get the most out of your university life and expose yourself to a plethora of experiences and knowledge in management and information technology.
Thank you for your undivided attention.
Now, to formally welcome the gathered audience, I have the pleasure of inviting the chair of today's conference, Dr. Amila Vittanarachi.
Good morning, everyone. Do you know there's only a handful of IEEE technically sponsored conferences in Sri Lanka? The question is, how could a single department, that is the Department of Industrial Management at the Faculty of Science, University of California, host an international research conference that is technically sponsored by IEEE, and the proceedings are indexed in Scopus? The distinguished guest, Senior Professor Sudat Kanigamudali, Dean, Faculty of Science, Senior Professor Kapila Seneviratne, Chairman, Research Council. Keynote speakers, Dr. Yasantha Karunanayaka, Vice President of Analog Inferences USA, Professor Saman Halagamuge, University of Melbourne, Australia. Representatives of the platinum sponsors to the conference, SLT Mobitel and MAS Lineaqua. Distinguished invitees and all the research community who are gathered here today and who are connecting with us online platforms. Now, to answer the question that I raised at the very beginning, let me take you to year 2018. The date was 29th March 2018, the day that we had our first conference. Just like the history of the department, we had a very humble beginning. Exactly 1 year after, that is on 29th March 2019, we had our second conference, and by then we were able to obtain IEEE technical sponsorship. Year 2020 was a year that shattered the whole world with the pandemic COVID-19. As the department, we could have good reasons to skip the conference that year. But as the Department of Industrial Management, we love taking challenges. As a matter of fact, we were embraced by the challenges. On 24th of September 2020, we marked a new milestone in today's era of digitalization by hosting the first ever virtual conference in the history of University of California. Today, it's our great pleasure to host the International Research Conference on Smart Computing and Systems Engineering for the 6th consecutive year. This is a remarkable year for the conference team as well as for the department. We received 193 papers from 20 prestigious institutions around the world. The papers are from countries such as the UK, Japan, Australia, India, etc. Out of the papers we received, we selected 56 papers with an acceptance rate of around 29%. Ladies and gentlemen, we are yet to answer the question that I raised at the very beginning. To answer that, allow me to quote a statement made by late Steve Jobs at his famous Stanford commencement address. He stated that, quote, "You can't connect the dots looking forward. You can only connect them by looking backward." When I look back on the remarkable journey of the research conference, there are 3 unique characteristics that fueled our success. That is, number 1, dedication. Number 2, passion. Number 3, teamwork. The teamwork of the academic and the non-academic staff, students, and the alumni. When it comes to the Department of Industry Management, this unique combination of staff, students, and the alumni, we call it as IEM family. Ladies and gentlemen, as of the concluding remarks of this welcome speech, I'm not going to wish this year's conference a success. Why? Because you can make a wish for the things that are uncertain. As a matter of fact, when we look into the 2 profound keynote speeches lined up for the day and the content of the 10 sessions that you are about to experience, we are 100% certain that we are going to mark another remarkable milestone in the history of SCSC conference series. Thank you, everyone.
We sincerely thank you, Dr. Amila, for delivering such a warm and inspiring welcome address.
Now, I would like to call upon on stage the Dean of the Faculty of Science of the University of Kelaniya, Professor Sudat Kalingamudali, to deliver his remarks to those present.
Thank you very much. Very good morning and greetings to you all. Dean of the Faculty of Graduate Studies, Chairman of the Research Council, Senior Professor Kapila Seniviratne, Dr. Yasantha Rajakarunanayake, Vice President, Machine Learning and Research and Development, Analog Inference, USA, Professor Saman Halgammu, Professor in Mechanical Engineering, University of Melbourne, Head of the Department, Professor Janaka Wijanayake, Conference Chairperson, Dr. Amila Vitanarachi, Conference Secretary, Dr. Thilini Mahanama, members of the academic and non-academic staff, research scholars, authors, and sponsors. As an alumnus of the University of Kelaniya, one of the finest national universities in Sri Lanka, I express my gratitude to the organizing committee for inviting me to the inaugural ceremony of the 6th edition of the Smart Computing and Systems Engineering 2023 conference. As mentioned previously, the primary objective of this conference is to provide a platform for research scholars, academics, researchers, and industry experts to present their research in the areas of smart computing and systems engineering. It is worth mentioning that the proceedings of the conference are published in the IEEE Explorer Digital Library and the paper acceptance rate was highly competitive with less than 30% of the papers being accepted. Currently, the Faculty of Science comprises 8 academic departments and 2 academic units, catering to over 2,500 undergraduates and 600 graduate students in various majors. This makes it one of Sri Lanka's most esteemed science faculties. The Department of Industrial Management, established in October 1967, has been instrumental in developing its academic programs over the years. Through regular program reviews and the enhancement of laboratory facilities, the department has grown significantly. Initially, as mentioned again at the welcome address, the department offered industrial management as one of the subjects in the 3-year bachelor's program to teach management for science graduates. In 1985, the 4-year bachelor's honors program in industrial management was introduced, and since then, many graduates of the BSc honors degree in industrial management have pursued their higher degrees and secured senior positions in prestigious institutes of higher learning and research, both in Sri Lanka and abroad. Many of them are back at Kelaniya. The Department of Industrial Management has been at the forefront of innovation. For instance, in 2004, it introduced the BSc Honours in Management and Information Technology program, which was the first degree program offered by a single department in my faculty. Furthermore, in 2020, the department was awarded the ISO 9001-2015 Quality Management Certificate. In conclusion, I would like to express my sincere gratitude to the organizing committee for successfully bringing this event to fruition, to extend my best wishes to all presenters and participants for a highly productive and fruitful day ahead. Thank you.
Thank you, Professor Kalingamudali, for your valuable comments on this momentous occasion.
It's now my pleasure to invite our esteemed guest, Professor Kapila Senaviratne, the Chairman of the Research Council, to address the gathering.
Good morning, ladies and gentlemen. Senior Professor Sudat Kalingamudali, Dean of the Faculty of Science, and our keynote speaker today, Dr. Raja Karuna Nayaka, Head of the Department, Professor Janaka Vijayanayaka, and Conference Chairman, Dr. Amila Vitananachi, and also Secretary Dr. Mahanam, and distinguished guests, invitees, participants, ladies and gentlemen. It is a great pleasure to be here. First of all, I congratulate the Department of Industrial Management for organizing this conference for the 6th consecutive time, and organizing a conference of this nature. It's like going through fire and water these days. It's a difficult task, and you have continued to excel. My congratulations. And also, this is the first time I visited this nicely designed building, and fresh fumes of furniture and all the volatiles invigorates me. Very nice to see you are developing really well. I'm sure that this research conference provides an excellent platform to our young researchers, student researchers, as well as senior researchers, to share their newly generated knowledge among both local and international community. As the chairman of the Research Council and also as a member of the ranking committee of the university, I'm delighted to hear that these conference proceedings are indexing prestigious indices, because at the end of the day, what is important is quality publications and also the research impact. Research impact, talking about research impact, and that reflects how other people use our knowledge for their own work and for their own findings as well. So publishing research in index conferences is extremely important for our ranking. So I really appreciate your effort. Talking about the Research Council provides various support, and it was established in 2014 with the aim of promoting research culture in the university and also supporting multidisciplinary approach of research. And it provides funding for this kind of conferences, as well as travel grants and publication charges as well, publication fees as well. And also we have appraisal systems to recognize researchers who generate high quality publications. So I'm really delighted that this conference, as Dr. Amila mentioned, this is the very first conference of the university which was recognized by IEEE Explorer. I'm very glad. And we need more and more such good work from the university. And as the Research Council, we are more than willing to support and also encourage this kind of work. And finally, I like to thank the Industrial Management, Department of Industrial Management for inviting me. And also, I like to congratulate our presenters and hope that this will be a very fruitful day for you. Thank you very much.
Thank you, sir, for those encouraging words.
It is with great pleasure that the Department of Industrial Management welcomes you to this prestigious international research conference, which we have the honor of hosting for the 6th consecutive time. We owe our deepest gratitude to the entire university community, led by the esteemed Vice Chancellor, Professor Nilanthi De Silva, whose unwavering support and invaluable contributions have made this event a possibility. Thus, on this significant occasion, I would like to extend our gratitude to Professor Nilanthi De Silva, the Vice Chancellor of the University of Kelaniya, who will be joining with us virtually to address the gathering.
Good morning, ladies and gentlemen. Professor Kalinga Mudali, Dean of the Faculty of Science, Professor Janaka Vijayanayaka, Head of the Department of Industrial Management, and colleagues of the academic staff in the Faculty of Science, keynote speakers Dr. Yasantha Rajakarunanayaka and Professor Saman Halgamuge, and other industry experts, research scholars, undergraduate and postgraduate students, and all participants in the 2023 International Research Conference on Smart Computing and Systems Engineering. First of all, my sincere apologies for not joining you in person. I'm part of the organizing committee for a different international conference on qualification frameworks and recognition of qualifications and credentials, which is happening on the 28th and 29th June, and my presence at the conference, which is being held in person in Colombo, unfortunately. Having said that, let me congratulate the Department of Industrial Management on conducting this research conference for the 6th time. I clearly recall how they continued undaunted during the COVID-19 pandemic, using the Zoom platform to connect everybody in the virtual mode. Fortunately, now we are able to meet in person and make use of the fact that we are all gathered together in one place to make best use of the opportunities for networking. The science faculty is one of the oldest in our university, and the Department of Industrial Management dates right back to the beginning of the science faculty. I know that the staff of the Department of Industrial Management, even though it is a old, very well established department, really pride themselves on offering programs of study that are highly relevant to today's business world and on conducting research that intertwines management with the latest developments in information technology. Every now and then, new technologies result in the disruption of the routines that we have grown used to over many years. But it is also a well-known fact that such technologies also create new opportunities that organizations must grab quickly if they are to remain competitive. Infusing smart computing and systems engineering solutions in business processes is one such area that is relevant to all organizations, whether they are corporate businesses like our sponsors, SLT, Mobitel, and MAS, or state sector entities such as our university. I'm told that the 6th conference will focus on digital transformation, Industry 4.0, big data analytics, smart systems and technologies, as well as transportation and logistics, systems modeling, and simulation. I'm also told that the conference organizers received 198 papers for presentation at the conference, but they were able to accept only 54, presumably because of constraints in time and space, and perhaps ensuring that they were up to the required standard, since this is a IEEE indexed conference. I would like to thank the 2 keynote speakers for giving us of their time and expertise and helping us to understand the latest developments in this field from a global perspective. Finally, let me thank the head and the staff of the Department of Industrial Management, especially the conference organizing committee, for all the hard work that I know they have put into organizing this conference. I know it's not easy, especially in the context of the financial constraints that we all face today. Finally, let me wish all the conference participants and resource persons a very fruitful day's deliberations and discussions. Thank you. And discussions. Thank you.
Express our heartfelt gratitude to Madam for graciously sharing her valuable insights with us and for her unwavering support in fostering a culture of cutting-edge research within our university community.
Today, we have the immense privilege of having 2 iconic personalities among us who have graciously accepted our invitation to be the keynote speakers at the prestigious International Research Conference on Smart Computing and Systems Engineering 2023. Allow us to introduce our first esteemed speaker, Dr. Yasantha Rajakarunanaike.
Dr. Yasantha Rajakarunanaike is a senior technologist and scientist with over 30 years of experience in the Bay Area high-tech industry. He is recognized for his innovative contributions and expertise in the field of artificial intelligence. He attended the University of Moratuwa and followed electronics engineering, subsequently receiving a scholarship for his dream university, Princeton University in the US. He's an expert in many key technical areas such as Wi-Fi, digital satellite communications, video, digital subscriber line, and has meaningfully contributed to fundamental technology and key product design and software through Silicon Valley companies, mainly during his tenures at MediaTek and Broadcom. He has experience in all parts of the internet, mobility, connectivity, and cloud ecosystems, from designing low-level hardware functional blocks to streamlining software driver architectures, server systems, and adaptive inferential systems of cloud and high-tech edge devices. Dr. Yasantha has a strong background in software and algorithm design and has developed and designed systems and algorithms that utilize AI in a variety of applications, including MM-wave radar systems, human speech recognition, and medical imaging. He has also been acknowledged as an expert mathematician in the high-tech industry. Dr. Yasantha's Problem-solving skills and ability to deliver results in fast-paced, high-pressure environments have been consistently demonstrated throughout his career.
He brings a wealth of knowledge and expertise in the field, and we are honored to have him share his valuable insights on innovation in the age of AI, unpacking 2023's AI innovations and their sweeping global implication. Dr. Yasantha, the stage is yours.
Huh? Good morning. I wish to thank University of Canada of the SCSC conference for inviting me today. It's my great pleasure to deliver the keynote for you. All right. So today hello. Yeah. Today my talk is about innovations in in AI, right? In 2023. 2023 is a banner year for AI. Essentially, there has been a lot of new developments. As you know, there's ChatGPT. You must have heard about it and tried this, which is a groundbreaking innovation. And many of these new things are catching on, and essentially our society is recognizing that AI is going to be playing an important role in our lives. So essentially, my talk today, I will try to introduce to you the impact of AI in the technological sphere, explain to you how some of the large language models work in a technical way, if possible, and then talk to you a little bit about some new innovations that are happening in 2023 in new research fields, essentially, like quantum computing and things like that. And then we'll wrap it up with a discussion on how AI is the future of AI. Okay, thanks. Yeah, so let me start with defining the AI. AI is the development of computer systems to perform tasks that traditionally require human intelligence, right? So essentially, I think the most important thing here is that the large language models, essentially, that to do AI, we thought initially that it was just a computational problem, but now it looks like we can approximate human language understanding with AI, right? So in that sense, AI is getting close to, essentially getting close to the human operating system, that is our language, right? So we can talk about AI being able to solve not only just a simple set of problems, but any problem that you can express in human language, right? So it's what we call AI completeness, right? So that it's not only for just a few problems, mathematical problems, but now we can ask it to solve political problems and other things. Yeah, so here's the global impact of AI. AI is supposed to get to $15 trillion, right? So the world GDP right now is about $100 trillion. Anybody know what Sri Lankan GDP is? It's about $134 billion. So it's 0.1 trillion. So it's about, the world is about 1,000 times bigger than Sri Lankan economy, right? But AI is going to be 15% of the world economy by 2030. And that was before these large language model innovations started. So what, with the large language models, people think that this can be about $30 trillion. So, that's equal to the economic output of Europe by 2030. So it's an exponentially growing field. And as you can see, AI is making a lot of impact in human creativity. There's AI art and many other aspects, right? So this is an interesting diagram where it shows you that productivity enhancements that are, maybe I'll just use this one. Okay, it's fine then. You can use it. Try now. Hello? Can try. Okay, good. Okay, good. Thank you. Yeah. Everybody can hear me, right? Yeah. Okay, good. Perfect. So, yeah. So for one, I want to talk about two applications of AI. Okay. The first one is essentially in solving diabetic blindness. Basically, every person who has diabetes is at the risk of going blind. Okay, there's a probability for that. And we just don't have enough doctors to diagnose this. If you diagnose it early, you can cure the disease in the sense that you can, treat the people, right? So AI allows you to, so the optometrists and eye doctors are expensive, right? As you can see in this diagram, countries like India have hundreds of millions of people that are at risk of going blind. So AI will allow you to solve this problem by imaging the retina of the patient. Okay, and there are very simple tools to take a camera with iPhone. Take a picture of the back of the eye, and then have machine learning and AI programs diagnose whether you have these things like macular degeneration or glaucoma or diabetic retinopathy, right? So that's very exciting. You can eliminate blindness from 400 million people in the world. It's a very, very, very good application. And this is how the AI diagnoses it, basically looking at the picture of the retina, and then it detects the deformities and then correlates that with the disease. Another favorite topic of mine, and especially in the university here, is to talk a little bit about how AI is used in education, can be used in education. So the classic problem of education is that anyone who teaches any course, you can see here that, so you have people who are bored, and people who are struggling. Sorry, people struggling here and people who are bored. And the teacher or the professor has to teach to the middle, right? And there's a bigger class. So the bigger the class is, it's very difficult to get the average and hit the both corners, right? So what AI will allow you to do is to have more smaller classes and more custom education. So I think by doing that, you will be less disengaged and you will essentially love the educational experience. Okay, so, and another thing that AI can do is that as we learn, we all need to memorize certain facts. We call it cramming for exams. And you can see the curve here. Essentially, once you study, in about 2 days, in new information, you lose in about 40%. It goes down to 40% in 2 days. Then you study it again, and then the second time around, you can see it's a lot better. You retain it for like 7 days. And then if you study the third time, then you can retain it for about a month, right? So what AI will allow you to do is to have custom exercises and testing programs so that you can learn for life, right? So that's one aspect. The other thing I want to talk here is that a lot of times people think that they can't do maths, right? And then the reason for that is because they got a bad teacher in the 7th grade or something. When you're supposed to be learning about quadratic equations, they didn't have a good algebra teacher. So when you go to grade 12, they can't learn calculus because they don't have the prerequisite. And the teacher who is teaching you at grade 12 is not able to, doesn't have the time to go and teach grade 7 stuff. So again, AI will allow you to go through your entire history of education and fill in the gaps, because a lot of times, when we are young, we have different growth stages and we are distracted, so I think it'll exponentially increase the human productivity and students' engagement and productivity. So I think the main point here is that the AI can make education a new human right for the 21st century, right? Education is not a human right at the moment, right? It's a privilege, but we should make it a right. So here's what the large language models like ChatGPT can do, GPT-4 here. It can pass the American bar exam, that's the law exam, at 90%, 90th percentile. There's one for doctors as well, and it can pass the doctor's exam at 90%. So now, as you can imagine, in a few weeks, not few weeks, few years, doctors and lawyers will have a hard time competing, because, or at least you can, it's going to change the field, right? Because if you're not in the top 10% of the doctors, then the AI is going to do better than you. So that's something to think about. So basically, job market will be impacted, right? And also creativity as well. We think that only human beings can create, but there's very beautiful AI created music, art. So it's a very exciting field. Okay, so I want to explain to you a little bit about the science behind how things like ChatGPT work, right? So essentially, what they are a vector database. So everybody knows what a database is. You have a query and a key and a value, right? So you ask a query, and then it matches the key. For key value pairs are stored in the database, so you go and read it and get the value out, right? So what a vector database is, essentially you take audio and send it through a machine learning model and create a vector, or text, or videos, all of them together into some fixed length vector. And then basically, here you can see a vector in a multi-dimensional vector space, okay? Where these three red arrows, right? This is a happy dog, is here. This is a happy person. So basically, a very happy person is here. So the happy person should be in between these two vectors, essentially, right? Because it's an in-between concept between a happy dog and a very happy person, right? So that's the concept. So we call it the cosine similarity. Basically, you do a dot product of these two vectors and find how close they are. And that's how language models understand the world. Okay, it's a mathematical dot product. So this is called a transformer. Essentially, this is architecture for machine learning. I'm not going to go through the details because I think it's better to talk to me later if you have any questions. But it's called the transformer, and attention, that is paying attention to what happened in the immediate past, allows you to predict the next word. So essentially, all of these things work by a next word prediction mechanism, right? In fact, when you and I converse, it's the same thing. I listen to you and then I say the next word, basically that most appropriate word. And that's how we converse with each other. It's the same way for AI, right? So humans are also kind of next word prediction machines, if you think about it, okay? So here I want to digress a little bit and talk to you about computation other than AI, because I think it's worthwhile for you for your research purposes to understand what's happening in 2023. So the fastest machines that are used in AI are able to do about 2,000 teraflops, okay? The flop is a floating point operation, okay? A teraflop is 10 to the 12, so we can do generally 10 to the 15 operations per second. That's how much you need for running a large language model network. So the new topics I want to discuss quickly and I hope I can do that very quickly, is talk to you a little bit about quantum computing, neuromorphic computing, and analog computing, and optical computing. So that, and then also some of these other aspects like in-memory computing and reduced precision. So in 2022, I think the Nobel Prize was awarded for quantum computing, essentially, for discovering a quantum computing effect called entanglement, right? So it's basically, yeah, let me explain how this is supposed to work. So traditionally, you have bits representing zeros and ones, right? So in the quantum mechanical sense, these two things are in a superposition. They are coupled, right? So you have a linear combination, and only when you do an observation, it goes into one of the eigenstates, right? So otherwise, these alpha and beta here are linear combinations, right? So this object is called a qubit, a quantum bit. So a quantum bit can have a capacity of 2 to the n classical bits. That's what I will explain to you how that works in the next. Yeah, I'm going to skip through this. I don't have time for this. Okay. The other thing about entanglement is that you have this action at a distance. You have this action at a distance. We think that information propagates at the speed of light, right? But quantum mechanically, what you do is you have a spin up and a spin down photons, and you shoot them out in 2 different directions. And then what we can have is that once you measure this to be red here, let's say in Africa or in the Middle East here, the other photon has gone to South Africa there, and basically they are coupled together, and we don't know how this happens, but it's a real physical effect, right? So some people have, these are speculations. There's a thing called superdeterminism or non-local. So for instance, Albert Einstein didn't like this at all, that, because it could be 1,000 miles away, and how did that system out there know about this system, right? There's no causality. So it's a very interesting field, but we can use it for computation, and that's the most interesting thing that I want to tell you today, right? So a qubit is like this. You have a 0 and 1 there. Now, if you have 3 coupled qubits, quantum bits, then typically you have only 8 states here, right? For classically 0, 1, 1, like 1, 1, 1. You have 8 states, but in the quantum case, you have 8. Basically, it's 8 quantum states, and you can think of them as 8-dimensional cube in the 8-dimensional space. So it's 2 to the 8 is the number of bits that a quantum qubit system has, right? So you can very quickly solve big problems like, if you have a system with 20 qubits, you can have a storage capacity of 1 million bits. Okay, so just it's always a 2 to the n of the classical number. So and so this is a very hot research topic, and in fact on the internet the IBM has put some computers free for you to run your own algorithms and play around. So when you're researching, please do that. I think it's very cool. This is what the state of the art is. People in silicon technology, you can only make 3 qubits, but there are other, people are doing some material science research. Okay, I'm going to quickly go through neuromorphic computing. Neuromorphic computing is basically modeling the human brain, right? So the computer is made up of this von Neumann architecture, which means that you store data in memory, and then and then you execute some code and then put it back in memory. So this is a very expensive operation, and that's not how the human brain works. Human brain works by having a neuron, and it fires across this synaptic gap here, and essentially the computation and the memory are happening in the same place, right? So people have made these sort of computers now, and this is a neuromorphic circuit for human speech recognition, right? So, and it seemed to work, and it works quite well. The Intel has made a chip as well. Okay, so, and then I want to talk a little bit about analog computing. Analog computing is basically something that I'm spearheading right now with analog inference. And basically, we are trying to apply it to computer vision applications as well as some computer language, large language models. But here's what happens. You train a neural network, and these things are called weights, right? So essentially, we are trying to recognize the 7 here in this picture, right? So people can write various kinds of handwriting, and then the 7 will be slightly different for different people, right? So you have 28 by 28 pixels, so there are 784 pixels, and we have the values called A1, A2, A3 up to A784, right? And we find the linear combinations that work for a 7, right? So if another person writes it, that'd be another instance of it. So there'll be thousands of different 7s, and we try to train to find the coefficients of W, right? That's how it works. Now, in analog, what we do is we convert this problem, instead of computing this, into a physical law. Like, you remember the Ohm's law or Kirchhoff's law? Basically, it's V is equal to I1 R1 plus I2 R2. So this equation here, it looks exactly like that, right? So if you can make W is equal to I's and A is equal to R, then the problem is solved for you without any effort on your part. So that's what analog computing is trying to do. There's optical computing also making a big deal this year. And optical computing is very interesting. You can't solve all problems, but you can solve some problems with 0 power. And also you can do it at speed of light. So it's very interesting. It doesn't scale well, it's big, right? So for instance, if you had a image here, and then, you can see a lens here, and then the same image is created out here, right? Now, if you wanted to compute if this was the input, and this is a convolution this is a blurry image, right? It's basically image and a convolution kernel, basically a Gaussian kernel or something. You're doing some computation. But you can achieve this with optical computer. Essentially, you can think of it as put a little pinhole camera out here, just this filter in here, and then it'll make this thing blurred. If you don't cover the pinhole, if you cover the pinhole and then leave the other thing open, the outside part, then it becomes like this. It becomes edge detector. So a lot of computational problems can be automatically solved by using laws of physics. So that's the basic idea of optical computing, right? And then you may say, well, that's only a very small specialized case, but it's not true. It's really a lot of problems can be broken down into image problems, like hurricanes and weather forecasting and things like that. So optical computing is also quite an interesting thing. Reduced precision arithmetic is another one that's gaining momentum. All right, so I think I'm down to the last 2 slides. So I want to talk a little bit about the societal impact of AI for our society, right? So at this point, people are worried about job losses, and I think I understand that. So one of the solutions is that perhaps we can tax the companies that are making jobs disappear, essentially, because you have to pay their salaries. So the company is trying to make profit by not paying workers labor salaries, right? Say, well, you displace 5 people, so you have to pay the taxes that those 5 people would have paid. I think Bill Gates is a proponent of this idea, right? So there's a lot of discussion going on. I just wanted to let you know that that's like a possibility. The utopian means basically the good things that AI can bring to you, right? So obviously it can help solve environmental problems, because environment is very hard to model, because there's local things and it's huge. It's connected to the whole Earth. So I think AI can help you in that, in the CO2 problem. So I want to illustrate this diagram here. This is how the GDP works. Basically, an economy produces GDP, right? And what goes into it is what we call technology. Technology has 3 components. Knowledge, right? That's the knowledge of how to do stuff. There's natural resources are required for having a GDP. And then you have societal infrastructure. These 3 things together. In addition to that, you need physical capital, right? So some capitalist has to come in and invest in a building or take the risk. Money is this purple guy here, and then the green thing here is labor. We need to have people do work, and also human capital means the knowledge, right? So what is AI going to do to this thing? Okay, so first of all, let me do the whole thing in one shot here. Okay, so it's going to increase knowledge because of AI. People will have a lot more knowledge. Also, you have societal infrastructure is not needed. You don't need to build roads and bridges and things like that if everybody is remotely working, and if AI is doing it, it's going to lower the cost of that, right? Human capital will go up because everybody will have a lot more education. Labor will come down, but overall effect is essentially to make the GDP go up. And that's really very nice. Okay, and then the final slide here is the current state. The AI revolution is gaining momentum in 2023. We are edging closer to partial AGI. AGI means when the AI becomes smarter than the smartest human, right? So we shouldn't be scared of it. I mean, there are many systems in the world that are smarter than humans, like our GPS system. You know, it knows all the roads. No human knows all the roads, right? So essentially, this is of historical significance, basically. And in 2023, we call it the fourth industrial revolution, and it's in full swing. Thank you. Any questions? Yeah, I can answer a couple of questions. Does anybody have any here? Yeah. Yes. Sure. Sure.
How the AI identify when I'm talking culture and for example,
Yeah. Yes.
the meaning of the same language, other meaning to one part and one key.
Yeah.
So how is there any technology behind the AI to distinguish this upset of the same language?
Yeah. Yeah, very good question. Yeah, absolutely. So the way the large language model works is it's just not a database lookup, right? It has a recursive, there are like 60 or 80 or 90 layers. And basically it's a very context sensitive filter, right? So we train it on the entire Wikipedia, right? There are people, I think Google has trained it on 4,000 languages. There are about 8,000 languages in the world. Not sure how many, 3,000 maybe, I'm sorry, right? A large number of languages are there. And basically the structure of the language is essentially the same. You know, you put the noun first or the object second and the verb last if you're doing Sinhalese. If you're doing English, you'll put the verb second, right? So the AI can understand, and it's called attention layer. Basically, it pays attention to the previous words and which one is the most relevant one, right? So these are very large. So, you know, about 200 billion parameters, right? Therefore, it's able to absorb the complexity that you're talking about, you know, and subcultures, and it just knows. It just becomes like a subset that you just need to focus on. Yeah, thanks. Okay, any more? Thank you very much. Okay. Yeah. Yes. You have to train essentially. Correct. The training set currently is Wikipedia, the entire Wikipedia, plus all the books written, the official good books, you know, like Shakespeare and you know, any history books, and you know, that's a training set. Plus internet conversations that people are having, that's been curated, you know, like, you know, billions of conversations. And that's the current training set for ChatGPT, for instance, right? But Yeah, but you can train it on you can train it on Tripitaka if you want, some Gatha or something, right? And then it'll learn that, and then it'll be able to quote you the correct thing. Thank you. Thanks. Bye.
Thank you, Dr. Yasantha, and we kindly request you to remain on stage to accept the token of appreciation. To do the honors, I invite the conference chair, Dr. Amila Vidanarachi.
We express our sincere gratitude to Dr. Yasantha Karunaanayake for his enlightening presentation. His expertise and profound analysis have undoubtedly given us perspectives and a deeper understanding.
Ladies and gentlemen, it is my great honor to introduce our distinguished second keynote speaker for this esteemed inauguration ceremony, Professor Saman Halgamuge. Professor Saman Halgamuge, Fellow of IEEE, IET, and AAIA, received a Bachelor's of Sciences Engineering degree in Electronics and Telecommunication from the University of Moratuwa, Sri Lanka, and a Diploma in Engineering and a PhD degree in Data Engineering from the Technical University of Darmstadt, Germany. He is currently a professor at the Department of Mechanical Engineering of the School of Electrical, Mechanical, and Infrastructure Engineering, the University of Melbourne. He is also listed as a top 2% most cited researcher for AI and image processing in the Stanford database, and his papers are cited 13,300 times with an H factor of 51. He was also a distinguished lecturer at the IEEE Computational Intelligence Society. His research interests are in AI and machine learning, including deep learning, optimization, big data analytics, and their applications in biomedicine and engineering. His leadership roles include head of the School of Engineering at Australian National University, and also he's the Associate Dean of the Engineering and IT School of the University of Moratuwa.
Today, Professor Saman Halgamuge will share his invaluable insights on the engrossing subject, emerging role of AI in sustainable energy, forecasting the output of rooftop solar panels. Professor Halgamuge will now join us virtually from Australia to enlighten the audience.
Thank you very much. Thank you very much for very generous introduction, and I hope you can hear me. And I will share my slides. Okay. So first of all, appreciate that you are inviting me to this talk, and I also appreciate my friends and collaborators in the audience. I have a grant with the University of Kelaniya, and Professor Kalinga is, I think, is present and is part of my collaboration with the University of Kelaniya. So now I have reduced my speaker, so I can't hear you. So if you can't hear me, please text me, and because otherwise the sound will vibrate between the two places. All right. So I'm going to talk about our work in energy areas, especially in sustainable energy. And I have a few names here because the primary my primary focus here would be a PhD completed by Dr. Manisha Pereira in our group. And so I'm also acknowledging the co-supervisors and other people who collaborated with us, and where they are from is obvious from the titles. And my background is in electrical engineering, even though I'm teaching in mechanical engineering. So that also shows about the places you can go to with AI. So you can go across different places and work in different departments, and that is quite obvious. Okay, all right. Now, first, I will give a few slides about 21st century AI and what do we expect. And then I jump into the sustainable energy applications we work on. And I'll be referring to the PhD works completed by 3 students. The first one is by Khalid Abdullah, and he's from UK, and first degree from Manchester, I believe. And so he completed his PhD on forecasting energy demand and storage. So when you see forecasting, you know that this is where the AI is involved in this work. And then my primary focus will be on forecasting rooftop solar energy generation. The PhD, as I mentioned, is completed by Manisha Pereira. And I will mention very briefly about some of the work done by another PhD student who was completed on electric vehicles and AI in Unduni. And finally, I will mention a little bit about some exciting work we are doing currently, focusing on developing countries and energy. And it's a PhD work ongoing by Wilbur Davis. Yeah, okay. So as you see, this is partially ongoing work, partially just very nearly completed work that I'm going to talk about. The first to mention a few things about AI, because we are an AI group, or even though my focus will be on sustainable energy today. What type of AI future we do not want? So just benefiting from the first keynote speaker who talked about large language models and ChatGPT and which is quite exciting development right now. So now I put this question to you: what type of AI we do not want? Okay. So few things here. AI that cannot explain its action. So we want AI to tell us why it is doing what it is doing. Okay, so because the reason for that is by closely looking at some of the AI used in the banking sector and in few other sectors, and you can conclude that they are discriminatory against women or people coming from areas that are known to be poor. And so it's very judgmental, discriminatory, because of the humans involved in it, right? And because humans are like that, and then AI copy that. So now we don't want that. So AI that is secretive and not transparent. So not only the AI can be discriminatory, but AI can also keep it a secret. So we don't want that as well. And AI that cannot learn as we go. So we want AI to improve. So as it goes, right? So we don't want AI that can harm humans and the world, and we do not want AI that can go out of control or outsmart its creators, that are us, okay? So now I put these things here because we are actually, our AI work and what we are doing is actually focused on all of that. But just like everything else, you can't have a professor without having some politics involved. So this is my politics involved. So this is my politics. I would say, as an engineer, I love machines, but I love humans more. So AI must be regulated. There's no question about it. So some of the work we are doing actually contribute to have this ability to control, regulate AI so that people are saved, okay? So if you don't know what is going on in that space, you can have a look at it. EU AI Act, which is coming towards the end of this year, I believe. Yeah, they're not perfect, but now the world has realized that AI need to be regulated. Things are happening right now. And I 100% agree with the first keynote speaker. Education is a human right. And at least I can tell you as an AI researcher, most of our work, and we are making open source. That means you have access to all our papers, you have access to our codes, all right? So it's a tradition in AI world that people make their work immediately available. Sometimes we don't even wait until papers get accepted. right? And we want other people to copy our work, copy our code, and improve and do better. All right. So in a way, it's probably very beautiful in AI research area that people do it that way consciously, not only us in academia, but also in companies like Google and so on. But obviously they don't give out everything. They keep patentable stuff for themselves, but many beautiful work coming from companies as well. And because they just leave it open for everyone to study. The companies can go back and learn back from these developments other people are doing. So that's the idea. So to give a glimpse of what we are doing, and we do work on generative models, and the associated AI area called unsupervised learning, and we have been doing this work for over 20 years in my group. So this is to give you an idea about our most recent paper that in a normal AI tradition, honoring that tradition, we just give out the paper before it is getting published. And so now this on the left-hand side, that is a famous example that we put up in our lectures to show that all these faces are fakes. That means they're not real, but they look real. They're generated by AI. So in the same way, we can also generate fake things that look real. And that sounds a bit familiar to you. And last time I talked about this was in China a couple of months ago. It's actually last month in May. And they do, they are quite interested in this because there are quite a bit of fakes coming from everywhere in the world. And these fakes are very, very smartly done. So I'm talking about goods. So for example, a perfume, a shoe, and you can do a fake that looks exactly like, the original. So it's not AI, it is done, right? So how do you recognize the difference between the deep fakes or very nicely done fakes? Deep fakes is what we use in AI. Very nicely done fake and real. There's a lot of work done in this space, but there is something else here, and what we call undercover deepfakes. So imagine it this way. So now you created a chocolate, all right, and that tastes like the original, the looks like the original, the packing, everything is perfect. Now you want to sell that, you want to bring that into market. One clever way that people are attempting to do that is not to give the whole lot of fakes, but to hide the fakes inside the true ones. So that is why we call it undercover fakes, right? And so we actually put these things together with the original, right? So still it is very profitable. So now our paper here, and this is work done by one of my postdocs, Sachit, Morator graduate, Rashindri, and Deshani, Tamasha, all Morator graduates and current PhD students, and in collaboration with NUS. And this paper, if you search for undercover deepfakes, our names, and you will find out and find it in archive, and not only the paper, but you also have access to the Python codes we developed on this. Okay, so open access to most AI works that's provided. All right, now I go to the main of my talk, and it's about energy. So I thought that I would use this cartoon just to cool it down. So we're talking about high technology, but when you look at it, that's the old-fashioned cloth drying technology. We use both wind and solar energy. Fantastic. So what it tell us is, and we need, it makes us as researchers, and it makes us humble to see that this is the same thing. We use the sun and the wind to do this thing, and we do that slightly differently right now. Okay, and we call it smarter. Okay, well, that you can debate about whether it's smarter or not, or whether it is a better way of doing it. That is a better way of doing it. That's a different issue. But now coming back to the energy in Australia. So something's very remarkable about Australia is when you look at hot regions. So if you look at these red regions, they are really, really hot. And so you might think, all right, that is unlivable. Yes, parts of that is unlivable, pretty much. But when you look at it, when you look at this red dot here, if we can put solar panels on this red dot, it can supply the energy demand, all the energy we need in Australia can be supplied with solar panels that we put on this inhabitable region, this red dot here, okay? Now, to make it even much nicer, the example, so if we can put solar panels to all this green circle, right, we can power the entire world. We can meet entire world's electricity demand. So now you might ask, why are we not doing that? Multiple reasons. One is this renewable energy, this energy we generate, are not that easily dispatchable. We can't send it to Finland that easy, okay? We can't send it to Sri Lanka that easy. We can't even send it to the other side of Australia that easily without a huge loss. So this is the issue. So it's not about generating the ability to generate solar power. It's about the ability to dispatch and make use of this energy. This is where the storage, the battery technology come into place. So, so this project that I only briefly mentioned, and we looked at the battery technology and also the managing the demand. Okay, so again, if you want to get more details, you have to go and read these papers, and they were published, and they're on IEEE Explore, where the conference proceedings will be published as well. So where we did quite a lot of investigations into the use of AI for forecasting battery degradation, as well as forecasting energy demands in Australia. My apologies for that. It's cold in Melbourne. I should have told you. It's very, very cold, even though I'm in a warmer room. So it's our winter. So now I want to tell you this small diagram to explain a problem, right? And problem that you may be aware of, but I thought that I would take this cartoon actually created by my student Khalid, and I'm still using because it's very nice to explain the story. So this is a solar panel. This is a little house, okay? And then we have the grid on the right-hand side. Not sure whether you see my mouse movement. All right, I don't want to spend too much time on this, but I think you can see on the right-hand side, the grid, the blue arrow giving us the electricity to our home. And then we have on top of our roof, solar panels. The red arrow gives us electricity from the solar panels. And then we use it. And then we also have a battery, QT. And this battery can be used as energy storage if we have too much solar energy. And we can also use this battery energy back when we need it. So that is roughly what we can do. So now I have no idea how this works in Sri Lanka, but in most countries on earth, you can actually have too much, but they are very clever. So here's an example. So you buy the electricity from the government grid or whatever company grid. It's 40 cents a kilowatt peak, 20 cents a kilowatt hour of peak. But if you sell it, they buy it back from you for 5 cents kilowatt hour per kilowatt hour. Okay. So this is very clear. You don't want to sell for 5 cents if you can store it using a battery and then use it. And if you really look at how this solar energy can be generated, it is also quite obvious. On a sunny day, of course, around 6, 7 a.m. in Sri Lanka, the sun comes up. So your generation starts and it peaks when the sun peaks. And then it goes down when sun goes down. So that's the generation. That's quite clear. But the demand, the electricity demand is very different. So electricity demand during the day could be not that high because most people leave the home or go away and go to work. And the demand goes up when people are back at home, putting on the TV and putting on the cooking. And if you have AC, you put AC on. And this demand is high when the sun goes down. So here you are. So there are a bunch of companies working in Australia and in everywhere in the world and trying to minimize your cost of energy by managing this. So there's two benefits you can see. One benefit is if you can buy electricity for 20 cents off peak and store it, and then use it when it is really needed. So when the demand is high, the electricity price is also high. So there's one benefit, benefit two. And benefit one would be if the electricity is really, really expensive and that point in time, and then you use your excess electricity. Okay, so rather than selling the excess electricity for 5 cents, and you keep it somewhere in a storage and then you reuse it, that is a huge benefit as well. So these both benefits are quite interesting because together, if you consider that together with the battery. So now you might say the batteries are expensive, right? But the good news is the battery costs are going down. So now you will have different strategies. This is only an example. In sunny day, this is what is happening as I explained. So your battery, your storage unit can store generated excess electricity, and then use it. All right, this is the level of the battery. Then use it very nicely when the demand is high, on a sunny day. But on a cloudy day, a rainy day, you cannot store electricity from from generated energy from solar panels, because it won't generate too much. So here the strategy will be different. If you know that it's going to be a cloudy day, what you do is when the tariff is low and you store energy into your battery, right? And then you use it when the tariff is high. So there's no solar energy involved in it, but still is part of the strategy. So this is giving you an example, but there's quite a bit of optimization you can do and quite a bit of AI involved, quite a bit of forecasting involved in this whole business area that many companies are benefiting from. So now coming back to Australia, it's a leading with rooftop solar per head. So it's a small country when it comes to population, similar to Sri Lanka's population, big country when it comes to land mass, but per person rooftop solar, Australia is leading in the world. So it plays a significant role and it is increasing. So 9.1% is in entire Australia. But if you go to the Western Australia, will be our focus. And I don't live in Western Australia. I live in Victoria, which is kind of a southeast. But Western Australia, we have data. We have we have access to lots of data, and their contribution to energy from rooftop solar is higher, 15.8 more than the national average. So this PhD that I mentioned that is the most recent one and is done by Manisha, and these are the co-supervisors. We looked at 3 issues. How do we actually increase the rooftop generated energy, and also how do you forecast how much energy we can generate using rooftop solar? Of course, all you need to know are in clouds. That's the slogan for me. So one problem we looked at, because if it's cloudy, you won't be generating enough energy. So the purpose of this talk is not to go into in depth of every single problem, because we publish one journal paper per this problem in this work. So one work is clearly looking at the clouds and how would cloud forecast? Can we forecast the cloud? So if this red curve here on the right hand side is how the cloud changes, and so there are multiple ways of forecasting and in different accuracies. Can we forecast the cloud formation accurately? And then if we know how the clouds are going to be in the next 12 hours, we can actually forecast the solar power generated by the panels on the roofs of the people in this particular area. So we are talking about Southwest Interconnected Grid. So that is basically Western Australian grid. So the first problem we looked at is, can we forecast clouds? So again, there is a paper, and I'm not going into details, but I'm saying that this is how we construct the study, and this is how we did it. And so the second one is to look at the focus on the region. So we publish a paper on this as well. So now that might sound a bit odd. What do you mean by region? So it's Western Australia is what we are looking at. So there's a big region, but then there are postcodes, and then there are the sampling points. So we can aggregate our whatever data we have, and we can look at it as a region. We can also look at and apply our deep learning per postcode and then add them up together. So how do we actually play with this different abilities? And how do we actually work on different levels of hierarchy in a region? So if you take Kalania as a region and Kiribati, where my hometown is probably one sub area of it. So if we actually forecast the solar power generation for Kiribati, and then Biagama, and then Unipitia and Mahara, and add them up together, and then we can probably get it for the entire Kalania region, right? But then again, if you look at the forecast, the weather forecast, that may be for the entire Kalania electoral division, right? And not for Kiribati or Biagama, right? So how do we actually play with this available different levels, different information available, and how do we incorporate deep learning into learn this? So what the PhD student did here is to create different deep learning architectures to actually handle this problem. And now this is a third problem we looked at in this particular task, is to actually make use of resolutions, different resolutions and horizons. So if the resolution is 15 minutes, horizon is 2 hours, and our forecast look like this. If the resolution is 1 hour and horizon is 1 day, and then we have a different forecast, all right? So it has an influence in it. So how do we actually find out the ideal horizon and ideal resolution? So this is another set of work. So what you need to do is to go and search for Manisha Pereira and my name, and then you should be able to find these papers on Google Scholar. And most of them are available, and I would say pretty much everything is available online. Not only that, and also the open source Python framework is available for most of this work. Okay, so I'm going too fast because I'm just giving you an overview of what we have done. And we have used here deep learning, and we have used here in this particular case, in the third problem, in addition to deep learning, we also use optimization, AI optimization methods, like, particle swarm optimization, all right? Okay, so I think I'm doing all right with time, I hope. And I'm going to talk about a few other things we have been doing using AI. And this is another project and a completed PhD by Nanduni. And these are the co-supervisors who worked with us on this. And this PhD project, we are looking at the potential of having lots of electric vehicles on the road, charging their EVs whenever they want, right? And how do we manage from the perspective of the grid? So this is a classic problem that everyone is trying to deal with, right? And and I don't own an EV, but I have seen enough charging stations, and I know how people do that. And so now, if everyone by chance decide to charge electric vehicle at the same time, we are in trouble. Okay, so the focus we had was what we call peak shaving. So if everyone are going to use the energy from the grid, because the EVs are parking at 6 p.m. at every home, and whenever they park in the garage, they plug in the charging into it. So how do we manage that? How do we shape the peak? How do we avoid peak happening? Because peak would mean that it might break down the grid. Okay, there are various other disadvantages, which I'm not going into. So we want to reduce this peak, and that way we can also keep the electricity costs less. And then we want to fill the valleys. So we want to avoid these unused areas. So we want to flatten this curve. And we worked on this on few different aspects. One is from the customer's perspective, because I want to charge my electric vehicle when I want, right? I don't want restrictions. And one from the grid's perspective, because the government is interested in keeping the electricity intact, all right? And the third aspect is also very interesting, and some of these papers are extremely highly cited, so we got it right here, the priority. And we were looking at social optimization, as we call it. Social optimization means we want to do well by customers and the industry that sells electricity, the government that regulates. So we want to do well by everyone. So how do we balance this up? Okay, so we are not going to provide a strong advantage to one person and disadvantage to others. So how do we do that? So the last thing I want to talk about here is some exciting work we are doing right now. And Will Bordeaux was in Kenya and Uganda and doing some having a field trip, and then we just put in a grant application to UK to fund some of this hardware that we want to get to do some real work in Uganda. So electrification, if you look at it, Uganda is 41.5, Kenya is slightly better, but this might look familiar to you. And then there is a big C word in all these countries. So let's not talk about Sri Lanka, talk about Africa. It's much easier. There's a big C. C stands for corruption. Okay, and it is unbelievable. And so you know, this cable meant to have some sort of insulation. My student has seen cables near trees without insulation. That means it was funded that way, but much of this money went to pockets of whoever it is, politicians or other officials. So the outcome is quite a disaster. So in this circumstance, how do we actually do something useful for these people? So how do you provide some sustainable energy? So it's a very challenging project that we are working on, very exciting as well. And there are a few practical examples. I think this is possibly from Pakistan or India. And so there are some advantages, because if there are no electrification in an area, now we want to provide electrification, let's jump to the cleanest possible option. And let's use whatever the possibility is to fund that. So my student is getting into an area called carbon credit. So you can go to an Africa and bigger village. We want to say, all right, the rest of the world has to pay for it, because they are now jumping into the clean energy. If you don't pay, and now they can do some dirty energy in it, and that will even make the planet worse off. And therefore, we're trying to work out various different channels. Can we actually use that advantage, clean energy advantage, to fund them? And we do use the AI in all these aspects. I have to tell you that. So this is an interesting one. Very popular vehicle in Africa, basically motorcycle. They change it a little bit. So now another project we are working on is to strengthen this. These are electrical charging places, so chargers. Can we actually make this in an EV based? All right, so I think I'll stop here. And I acknowledge all our funders. So mostly Australian Research Council, but because I do biomedical research work, and I'm also funded by this Health and Medical Research Council. And we get some money from industry. So Your Gene Biosciences, it's a company founded by my first PhD student, Bill Chung. And it's quite wealthy business. So they come back and fund supervisors research at University of Melbourne. So that's really nice story. So Google US, we got some money, IBM Australia, Robert Bosch Germany, POSCO South Korea, and it's a steel manufacturing company out of the blue. They wanted to have some of our help. And this is a grant that has started very recently, and I don't do defense. But if the biomedical research program of US Department of Defense want to fund us, we say, yes, you can fund our work. So, and lots of other funding and external collaborations. I did mention University of Kelaniya, but I have a collaboration with University of Kelaniya as well. Thank you very much. Very happy to answer any questions you have.
Professor Halgamuge has directed if there are any questions from the audience members or the heads are welcome. So does any of the audience members have any questions to be directed towards Professor Halgamuge? Yes, we have one question. So can we get someone from the technical team with a microphone? Yes.
Hope you can hear me. Yeah, thank you very much, Professor, for your presentation. I would like to ask, like, how can we implement this type of model in Sri Lankan context? Like, can we simply implement this model in Sri Lankan context? If not, what type of parameters that we need to change? Thank you.
Okay, so when you say this type of model, so I'm trying to understand what are you referring to? Could you further clarify that, please?
Okay. For example, like, I mean, you have implemented a deep learning model in Australian context. Now, if you can you simply apply that into the Sri Lankan context? If not, what type of parameters that we would have to change? Thank you.
Thank you. So I did not give you enough information about the deep learning model that we used. So I think the most complex deep learning model we use is in the second problem I mentioned. How do we cleverly combine different data sets available in different regions? All right. So I took this example, Kelaniya as a region, and then Biagama, Kiribati, Goda, Hunupiti, and so on, the other smaller areas. And there the architecture is designed to the application. So all deep learning, but it's a mixture of convolutional neural networks and then what we call fully connected layers. But then there are multiple models working together. All right. So you have to look at the paper in order to go to that detail. So now the question is, can we adapt that into Sri Lankan context? I think there are enough information there that will give you a good start if you want to do that in Sri Lanka. So now there's another caveat here. So the reason we went to Western Australia, and even though I live in Melbourne, not to go to Melbourne, was because the data was available first. And Western Australia is warmer than here. And in my place, and lots of data available. That is one of the major reasons we looked at. And how do we access the data? If I recall, IBM, because we worked with IBM actually bought this data from a company. So now in Sri Lanka, you may not be able to do that if you don't have access to data. Exactly copy that. But there may be main idea can be used definitely somewhere in Sri Lanka. So the idea here is to use multiple deep learning models and combine them to solve a bigger problem cleverly. So it's the innovation there is in the architecture of the AI tool design. So the AI architecture is not just one deep learning network, it's multiple combining them. For some, you can feed in the weather data. Right, the weather data is, for example, is available for entire Kelaniya, and then it will be fed into the Kelaniya network, right? And for the Kiribati Goda network, it could be just the user data available, and there's multiple data points that we get. For example, the wind speeds and weather is one thing, the wind speed is another data point, but also the electricity fed in by the generating customers, right? Generating households and historical data. So this is all about predicting how it is going to go in future, right? And why it is important. So once you can predict how this electricity can be generated from individual households, and then the government can plan better and change policies and probably think about installing batteries in certain areas and manage the electricity better and make it cheaper in the long run. Because unplanned electricity demand management would mean that the electricity price goes up all the time. That is happening in Australia as well. Because we have no solution for the peak. Australia, for example, we know when this is going to get worse because there's one day that is the hottest day in summer in Melbourne, and where we have absolutely no way of changing the electricity, lowering the electricity, because around midnight it's very hot and then everyone has the AC on. That is the peak. And then what the government decides or companies decide, okay, we need more infrastructure, right? So we have to buy more, we have to make more investment, and then they pass that cost on the customers. So the electricity price keeps going up and up and up. So it's our fault, you could say. So if we don't switch on the electricity on the same time, then we will manage. So it is important to forecast the demand as well as the generation, okay? And then that way we can manage the prices. So that is the motivation behind us. So I think it's a bit too hard for me to exactly answer your question because we don't know what is the amount of data and level of information available in the Sri Lankan context.
Thank you, Professor Halgamuge, for that answer. And unfortunately, given the time constraints, we are not able to take any more questions. But thank you so much, Mr. Dinesh, for asking that question. And thank you so much, Professor Halgamuge, for sharing some of the most crucial information regarding the role of AI in sustainable energy.
As we come to the end of this momentous inauguration ceremony, we would like to invite Dr. Thilini Mahanama, the conference secretary, to deliver the vote of thanks and express our gratitude on behalf of the organizing committee.
A very good morning to all of you. Dean, Faculty of Science, Professor Kalinga Mudali, our keynote speakers, Dr. Yasantha Rajakarunanayake, Vice President, Machine Learning and Research and Development, Analog Inference, United States, Professor Saman Halgamuge, a professor in Department of Mechanical Engineering, University of Melbourne, Australia, Deans of Faculties, Heads of Departments, members of the Technical Program Committee, technical sponsors and our platinum sponsors, researchers and distinguished guests, academic and non-academic staff, ladies and gentlemen. It's my immense pleasure to deliver the vote of thanks for the 6th International Research Conference on Smart Computing and Systems Engineering 2023. On behalf of the conference committee, first and foremost, let me thank our Vice Chancellor, Senior Professor Nilanthi De Silva, for her continuous support. Her emphasis on enhancing the university's research profile motivates us to continuously enhance the standards of SCSC conference each year. My heartfelt gratitude goes to the Dean of the Faculty of Science, Senior Professor Sudat Kalingamudali, for the immense encouragement and the guidance as always. I would also like to thank the Chairman of the Research Council, Professor Kapila Senaviratne, for his valuable support to make this conference a success. I am extremely grateful to our keynote speakers, Dr. Yasantha Rajakarunanayake. Thank you very much for sharing your invaluable insights on innovations in the age of AI. Professor Saman Halgamuge, thank you very much for your keynote address on the emerging role of AI in sustainable energy. We are so honored to have both of our keynote speakers at SCSC 2023. I would also like to thank all the deans of faculties, heads of departments, and all the academic and non-academic staff of the university for their valuable support. I thank the advisory committee, program committee, reviewers, editorial board, and session chairs of SCSC 2023 for their commendable support and constructive feedback. I'm also thankful to our technical sponsors, IEEE and IEEE Sri Lanka section, our platinum sponsors, MS Lineaqua and SLT Mobitel, for the tremendous support provided to make this a success. I express my sincere thanks to all authors and presenters for joining us to publish their research and for their immense support. Thank you very much, Trident Private Limited, for encouraging our researchers by sponsoring for the Best Paper Award at SCSC 2023. Our conference would not have been a reality if not the support of the entire team at the Department of Industrial Management. Thank you for the entire team headed by Professor Janaka Vijayanayaka for the commitment and passion to make this event a tremendous success. I would like to especially thank the conference chair, Dr. Amula Vitanarachi, for his leadership, and the technical program chair, track chairs, and the entire conference committee of SCSC 2023 for the immense commitment throughout the journey. A special thanks goes to Ms. Dinesh Asanka and Ms. Hiruni Nyunhella for organizing and conducting the pre-conference workshops. Thank you very much for the superb technical team headed by Mr. Buddhika Jayawardena and my fellow secretarial team. We would like to thank and acknowledge all our invitees for your presence for gracing this occasion. Last but not least, let me express my heartfelt gratitude for the staff and students of the Department of Industrial Management, IM family, for your hard work in making this a success. Without you, the teamwork that we witnessed today would not have been possible. Thank you very much once again, ladies and gentlemen. We hope you will experience an insightful encounter today at SCSC 2023. We hope to see you again at the SCSC 2024. Have a pleasant day. Thank you.
Thank you very much, Madam.
Ladies and gentlemen, and with that, we bring the inauguration ceremony of the 6th International Research Conference on Smart Computing and Systems Engineering 2023 to a close. The organizing committee sincerely hopes that this conference serves as a vibrant platform for you to explore, discuss, and ultimately bring your ideas to fruitful and productive conclusions. As we conclude the proceedings, we kindly request everyone to rise for the national anthem.
Sri Lanka, Namo, 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 Namo,
We wish you all an enriching and insightful experience throughout the day.
And ladies and gentlemen, please join us for refreshments outside. We hope 45 a.m. onwards. May you have a beneficial and a productive day ahead.